This video will be the start of a new set of videos that I'm going to do where I am actually working out the problems, um, and hopefully you seeing how I work these problems that were in our homework will help you to figure out how to move forward working problems and so forth with your homework. And so this is the first week, chapter 1, and this will also be the answers to the homework um, for each chapter as we go along. So today we're doing chapter 1, and the first problem is number 2. And number 2 states that a car is traveling at a speed of 33 meters per second. What is its speed in kilometers per hour? And is it exceeding the 90 kilometer per hour speed limit? So in order to do the first part of this problem, we start out with the 33 meters per second, and we multiply that by the fact that there are 1,000 meters in a kilometer, and then also that there are 3,600 seconds in an hour. And so the seconds cancel, and the meters cancel, and so you end up multiplying 33 by 3.6, and the answer is 118.8. And the initial was given in 2 significant figures, and so we have to reduce this to 2 significant figures, which is 120 kilometers per hour. Remember the label. The second question was, is this greater than the speed limit, which was 90 kilometers per hour? And of course, or obviously, the answer is yes. The next problem states, and it's number 4, and it states that an American football player, or American football, is played on a 100-yard field, excluding the end zones. How long is the field in meters, assuming that 1 meter equals 3.281 feet? So it's a 100-yard field, and we multiply that by the fact that there are 3 feet in a yard, so 1 yard is equal to 3 feet, and then there are 3.281 feet in a meter, and we cancel these out. We're left with the length of the field in meters. If you do the math here, it is 91.4355 meters. Now the initial length is given in 1 significant figure, 100 yards. So you can only have 1 significant figure in your answer, or 90 meters. Now, this week's homework I will not take off for significant figure mistakes. In the future, we will be deducting if you have a significant figure or a lack of a label. If you do 2 of those, that's a half a point deduction. So 1 will be no deduction, but 2 will be half a point deduction, etc. Okay, number 5. Soccer fields vary in size. A large soccer field is 115 meters long, so it's 115 meters long, and 85 meters wide. 85 meters wide. What are the dimensions in feet and inches, assuming that 1 meter equals 3.281 feet? So it's the same conversion as this. So if we start with the length first, we have 115 meters, and then 1 meter is equal to 3.281 feet. And if we do the math on that, 1 meter equals 281 feet, that gives us 377.3 feet, which to 3 significant figures would be 377 feet. Now, if you wanted to look at this in terms of inches, you could take this same 377.3 feet and multiply that by 12 inches per foot, and that would give you 4,530 inches. And that was correct. Actually, the calculator says 4,528, and we changed that to three significant figures, so it's 4,530 feet. The 85-foot wide part, or 85 meter wide, you do the same calculation, 3.281 feet in 1 meter. And if you do that, you'll get 278.9 feet, which corrected to three significant figures is 279 feet. You take the 278.9 feet and multiply that by 12 inches per foot, and you get 3,346 inches, which corrected to two significant figures is 3,300 inches. And actually I should have corrected this to two significant figures, and this should have been 280 feet. So it's 280 feet by 3,300 or 3,300 inches. So that's number 5. Now we skip down to number 12. And 12 says a good quality tape measure can be off by approximately 0.5 centimeters over a distance of 20 meters. What is the percentage of uncertainty? Well, first of all, let me roll this up so we have some new paper here. And we're doing number 12. So percent uncertainty, the formula states is that is equal to the actual uncertainty, which is delta A, over the measurement distance. In this case, it's going to be, or times 100. And in this case, it'll be 0.5 centimeters over 20 meters times 100. Now you have to change either the meters to centimeters or the centimeters to meters. It doesn't matter which one you do, but so let's say we change the centimeters to meters, that's going to be 0.005 meters, dividing this number by 100 over 20 times 100. And if you do the calculation here, you get 0.025% uncertainty. So 0.025% uncertainty. Number 13 states that a car speedometer has a 5% uncertainty. So the percent uncertainty for number 13, the percent uncertainty is 5%. Let me rewrite that a little better. So the percent uncertainty is 5%. And the question is, what range of possible speeds will read 90 kilometers per hour? So what we want to take this formula and calculate delta here. So that would be equal to the percent uncertainty divided by 100 times A is going to be the delta A. Okay? The percent uncertainty here is 5 divided by 100, and our A here is 90. We're looking at 90 kilometers per hour. And so if you do the math on this, you're going to get 4.5 plus or minus 4.5. And so that means the range of speeds is going to be 85.5, which is 90 minus 4.5, to 94.5, which is 85. So the actual speed when it reaches 90 can be anywhere in between 85.5 and 94.5. The second part of the question is to convert this to miles per hour. So if we take 85.5 kilometers per hour, to convert that to miles per hour, we multiply by 0.6214 miles per kilometer. So we're going to multiply that. That's going to give us 53.1 mph. And if we do the same thing with 94.5, so 94.5 times 0.6214, we're going to get 58.7 mph. So the range there will be 53.1 miles per hour to 58.7 miles per hour if it's reading 90 kilometers per hour. And if you wanted to know what that is, you just multiply 90 by this. It's approximately 55 or so miles per hour. So that's number 13. The next one is number 17, which is pretty straightforward. Number 17 just asks the number of significant figures. It says, state how many significant figures are proper in the resulting calculations. So the first one, you have two numbers multiplied together divided by two other numbers multiplied together. The first number, 106.7, has four significant figures. 98.2 has three, divided by 46.210 has 5, and divided by 1.01 has 3. And the rule is that it's limited by the one with the least significant figures, in this case either 98.2 or 1.01. So both cases for A, the answer should be expressed in three significant figures. B is just 18.7 squared. Now squared is a multiplication, so it's governed by the same multiplication rules. So 18.7 has three significant figures, so the answer of that should have three significant figures. The last one is 1.60 times 10 to the minus 19 times 3,712. So that first number has three significant figures. The second one has four, so again, it's 3. So the answer to all three of these is three significant figures. Now, before I give you a break and move on to the next part, let's do one more problem, and then I'll do the next set on a separate video. So the next one is 23. Now 23 states, if a marathon runner averages 9.5 miles per hour, which is a blistering marathon pace, by the way, how long does it take him or her to run a 26.22 mile marathon? Well, this is pretty straightforward. It's 26.22 miles, and you multiply that. That's one marathon, and this person is running 9.5 miles per hour. And so the miles cancel out. And if you divide that, you should get 2.76, but because this is 9.5, two significant figures, it's going to be 2.8 hours, which is a very respectable marathon time. So at this point, I'm going to stop the video to let you all take a break, or so I can take a break, and then we'll do the next set of problems on the next video.